Between 60 million and 30 million years ago, atmospheric carbon dioxide on Earth entered another peak phase. The tertiary coal-forming period began. Roughly 10 million years ago, coal-forming processes came to an end. Carbon dioxide dropped to an extremely low level. The quaternary glaciation and mass biological extinction set in. It was not until 8,000 years ago that glaciers started to melt. Humanity experienced great floods and rising sea levels. This was followed by long-term shifts between cultivated land and desert, and repeated struggles between hunting-gathering and agrarian civilizations. Starting from the 1960s, humans entered the industrial age. Large-scale extraction and consumption of fossil fuels drove atmospheric carbon dioxide to rise rapidly once again. Today, we are fully experiencing the resulting changes: climate warming, desert retreat, thriving vegetation, and increased precipitation. Atmospheric carbon dioxide fluctuates up and down around the trend line. The amplitude at each transition point remains broadly similar. Thus, we can estimate the magnitude of the next transition from the amplitude observed at the previous turning point. We will illustrate this with the graph. The unit here is 10,000 years. Over this segment, the unit switches to years. We can therefore see this trend line, which shows a broken line at this position. If plotted with consistent units, it would appear as one continuous downtrend line. From this trend line, during the tertiary coal-forming period, when carbon dioxide reached this level, namely 520 parts per million above the trend line, large-scale coal formation commenced. Carbon dioxide then declined, while oxygen levels rose. Its transition point lies here. Following this pattern, let us explore where the next carbon dioxide transition point will occur. When carbon dioxide rises again to 520 parts per million, it will reverse direction. Driven by improved photosynthetic efficiency, carbon dioxide will shift from rising to falling, ushering in a new era of flourishing vegetation. According to projections by Western scholars, without human intervention, by the year 2100, atmospheric carbon dioxide concentration will hit 950 parts per million under current conditions. If we enforce controls strictly in line with the Paris Agreement, by 2100, atmospheric carbon dioxide concentration will reach roughly 720 parts per million. According to our model, however, by 2100, atmospheric carbon dioxide concentration will not exceed 610 parts per million. That means, even without human intervention, Earth's carbon dioxide level will not reach the concentration projected under the Paris Agreement. Before reaching such levels, at roughly 610 parts per million, improved photosynthetic efficiency will curb further carbon dioxide growth and push Earth's ecosystem toward a flourishing phase. The above projections and carbon cycle model are from the book Carbon Cycle, published by a research group under the Shanxi Clean Energy Association. Models presented in this book indicate that Earth's carbon cycle possesses powerful self-regulating capacity. Rising photosynthetic efficiency fuels biomass prosperity. Greater biomass absorbs large volumes of carbon dioxide, driving down atmospheric carbon dioxide concentrations and lowering costs for bioenergy. This accelerates the rapid development of bioenergy. Eventually, bioenergy will become cheaper than fossil fuels and consequently replace fossil fuels.